solar powered power bank, rechargeable power bank. It has got two output. One is an 12-volt output socket, and the other one, it gives you 5-volt output at 2.1 amp or 1 amp. How do you get this voltage? In your pack, you will have received these batteries. You connect them in series, each being 3.7, which can go up to 4 volts for 4.2 at an average of 4 volts. So 3 of them will give you, in series, will give you 4, 8, 12, which is fed in there. And it's regulated to form 5 volt by this circuit. That is for your cell phone charger. Right at the input, you wire in your solar panel, the bigger one. There are two versions of solar panel which that has been sent, smaller ones and bigger one. So the bigger one is meant for 12 volt and the smaller one will be meant for 8 volt. That we'll be discussing later. Now, let's move to the 8 volt power bank. The 8 volt is more or less the same in terms of the output, but in the input is different. Here, you clip down this and insert a cable. Black, any black, it's gonna be for negative. So they are bridged inside. And any red is gonna be for positive. And you adjust your charge current using this port. So the output of a charger voltage of a charger will be increased when you go one way with this knob. You will figure it out which direction to go. Inside, now it has got only two batteries. So about our 4, 8, which goes there. And then downsized as well, again to a regulator for cell phone. As you can see, it's charging for cell phone is on 4%. And give you 1 amp. I'll advise you not to use the bigger smartphone there. Get small phone, which can be charged via this cable at a lower current. So now, what do you do with this? We're going to that as an example, but it's connected to the bigger panel, which is not recommended. I said use small panels for this. In series with the panel, you have an ammeter to measure the charging current from the solar panel. Now, this is what will happen. The current will be initially high when the batteries are low. As the batteries get fully charged, and then from there, the current will drop to about 0. Then you know the batteries are fully charged. Alternatively, you can measure the voltage right there. So 2 cells give you about 8 volts. If you get 8 volts, let's put it on 8.4 at an average of 4.2 per battery. You know that the batteries are fully charged. So, so you will have to measure the time it takes to charge this, right? And then afterwards, you connect your load. Your load will draw current, and you check how long it takes to draw that current. So firstly, you use a solar panel, you charge, you check the time it took you to charge, draw current. While the solar panel is connected, and you check the time it's gonna take for you to take all the current. So you start with the lights maybe here. Those lights bulbs which are supplied, connect them in series for lighter load, and then you go to your cell phone. It might happen that when you use the light bulbs, the batteries stay charged, and then you don't get to a point where they don't have charge. So it's possible, right? After those exercises, so you use solar panel, and then you repeat the same exercise for charging, and then connecting load when you are powered with electricity. So that's a hybrid system. You're going to compare the performance of solar how long it takes to charge and how long it takes to fully discharge. You compare with the electricity. You think of a battery in the air of wind in the meantime, how we're going to do that exercise. So, well, I think you can choose, you use this with smaller panel, or you can use this